Hi, my name is Freddy Fredrickson. I'm here in Alfred, New York in my shop. Over the years, the people that I've known here have been so helpful that I am grateful to them for teaching me everything. I wanted to pass along some of the more useful stuff that I have. One of my friends, Eddie, was interested in making elements in his factory, and I thought one of the easier ways to share the information would be to make a video, and while we're at it, post it on YouTube. So it's kind of a hybrid. It's going to be a little bit too much for a beginner and probably not enough for Eddie. But let's get started. This is a demonstration of physically how to make an element. This is not a demonstration of how to electrically calculate elements. I could probably talk about that for 30 minutes extra, and perhaps someday we will. But this is a device that I came up with my friend Al Ormsby years ago for making elements. And we have a wide range of sizes that we can use. I have rods that are 7/16 of an inch thick, and rods that are actually 7/32 of an inch. Everything in between, 1/4 inch, 3/8, 7/16, 5/16. So that determines how long an element will be by the diameter. The other consideration is the gauge of wire, and we have a wide variety of wire gauges stored in here. We're due for a shipment of wire as well, but we have 11 gauge, 12, 13, 14, 15, and 16 gauge wire. It's very thin and rather thick. These are some of the elements that we typically have in stock. These are ones that I use in my kilns. This is a real typical element for pottery kilns. These are 20 ohms, 14 gauge wire, and 3/8 inch. For front loading kilns, this is what you'll typically see. All the kilns that I make either are 13 gauge or 14 gauge, depending on 240 volt or 208. These elements are a little heavier, a little wider, mostly less resistance, and they have a twisted end on them. So I'll show you how to do that today. If we step over here, we'll see I have a collection of elements here that I set out, showing some of the different diameters, going from our heaviest one, 11 gauge, to our lightest one, 16 gauge. Electrically, they can be the same. Typically, in this case, you can get a lot more power. We're interested in what power is coming off the surface of this wire, and that's one of the calculations that we're not going to talk about today. We're going to physically make elements. So this is the contraption, spring winder technically, I guess, or in essence, it's a very simple lathe, but we're not really cutting material. A lot of times people are trying to wind elements on lathes, and that makes sense. I have a spool of wire up above that's on a sloped pipe. So as I'm winding the element, it actually comes downhill. This is the driver motor, and it has a right angle gearbox. I'm looking for something that goes pretty slow. Offhand, I don't know the RPMs, but very minor. So the rods are put into here, this 1/4 inch rod. There's a flat on here. And so that's typically how that's driven. This is an adapter to go from 1/2 inch down to 1/4 inch. The wire is fed through on this little mandrel. It's fed through this thimble. And if we look at another one, it might be a little bit easier. you can see that the wire will come in that rod and it'll get fed around the rod as the rod is spinning. Okay. This is a little bit of a trick in here, how this is a deeper cut in the circumference here than it is up here. So to make these, you'll have to think that through a little bit. So these are from 16 gauge to 11 gauge, and these are the rod sizes. So 14 gauge 16 is my smallest one. 11 gauge on a 7/16 rod is my largest one. So I can't wind these heavy wires on this smaller rod. I can't wind these fine wires on this larger rod, although obviously somebody had me do it sometime. These numbers on here represent how many inches on this rod will equal 1 ohm. That's all trial and error, and we've arrived at these numbers. Keep in mind that every spool of wire is a little bit different, and sometimes the resistance changes within the spool. Down below here, I have a foot switch that as I'm winding the length of this element, I can step on this bar anywhere along that length. This is my rewritten order from Kiln Manufacturing Company. They want quantity of 3 or quantity of 10. This is their part number. This is the resistance in ohms. This is the final length that the element has to be. 16 gauge wire has to be 167 inches stretched out. I have to be careful when I'm winding the element that the coils are absolutely as tight as they can be, because I'm relying on this 2 inches per wound length for 1 ohm. So if I use 2.04 inches, and I need 28.8, 57 inches for 28. Okay. So at 2.04, 28.8, I actually need 59 inches of wire. I measure out here 59 inches, and I have a little indicator I use to stop, to give me a mark for where to stop. Okay, to begin the process, I need to have the wire come through this thimble and wrap around one of these bolts. As I take the wire out, I'm careful never to let it go, or it'll unspool and create a rat's nest, which is nothing but trouble. Okay, so I need to feed this through at an angle, and then I wrap it around one of these bolts. Now be careful. When this is spinning, you want this aimed away from you. I'm going to move this down. This represents, all of this groove represents how much that's worn, probably over a year's time. We continuously are making new thimbles, and I want the thimble to aim right to the wire source. I don't want it here where it'll get sloppy, nor do I want it way down there, so that wire has to do this curve and would erode the bronze material faster. Both these thimbles and some of the other parts that we use for fabrication are all made out of bronze, so that the metal touching the wire is softer than the wire itself. To get started, I don't want to hold this with my hand. I could, but I've find it's much easier on me to just put a vice grip on there and let that travel along with it. As I step on the foot pedal, I want to keep control of this stuff. I want to keep a hand on it, keep my hand in it. I don't want this wire to get spinning too fast and create a rat's nest. And I also need to keep a little bit of left hand pressure so I don't get any space between the coils. It bounces a little bit. I've just learned to live with that. Keep a little bit of left hand pressure. I could spend some time trying to bend that back into position, and I probably should. But it gets bent every time we get a tangle up here. By the time we let off the pressure, it's pulling the rod up towards that spool of wire. I want it to be able to bend so it doesn't break. This wooden post underneath there on a lathe would be called a steady rest. I'm just kind of driving over it. They come into play a lot more on real heavy wires. I have to keep them closed up like that. I'm getting close. And the first element that I make, I usually run it a little past and I keep track of that. And then I show how much I can remove each time, trying to get less and less waste. Okay, so this is the finished wound element. Now to take this off, we have to be aware there's a little bit of wind up in the element as well as the spool. I really want to keep this spool from getting tangled up. So I pull off enough for my double wound end. I hold it, and I kind of hold it between my fingers. I take this end, there's holes in the spool, I feed that through. Get that out of the way. Now, I haven't let go of this one yet. There's a little bit of wind up in it. Okay. This wire is pretty safe. The 11 gauge, it'll lacerate you. You really want to practice up on these smaller gauges and then work your way up to heavier gauges. There'll be a little bit of wind up here as well, but not a crazy amount. Okay. To pull it off, they often come off easy. If there's a little bend in the wire, it's difficult. And then I have to work the wire back through that hole. Okay. Don't let these get messed up. This is our finished wound element physically. It's not finished electrically. It's probably a little bit long. Remember I said we needed to keep this so very tight as we wound it, and that's really well crafted and well made and very tight. I need 28.8 ohms, so I'm going to electrically measure it. To measure it, I need air in between it. If I just measured it like this, the electricity going through it to measure the resistance would literally just short circuit through the coils. So I'm going to give it just a little bit of stretch. Before I measure it, so that there's no way the electricity can short circuit through that coil. This is my ohm meter. I've made this setup for measuring the resistance of the coils. You connect one lead at about the thickness of the wall, 4.5 inches. And we use the other clamp to find 28.8 ohms. Okay, right there. That's 28.8 there. I'm going to back off just a little bit because that's going to make up for the pigtail. And I'm going to unwind it a little bit. Okay. So this whole system is a lot of contraptions. And this is a specialized little contraption here. Again, all of these parts that come into contact with the element are bronze or brass. These are actually mounting bolts for a toilet bowl. For a floor mounted toilet bowl. I've got a little hole that I drilled right in there, in that flange. So I need to use this extra part of the wire to make my pigtail. So I'm going to clamp it like that. This is a bronze tool as well. And I just pull backwards and unwind some of the element. We're going to save this for a minute. And I am going to put the other end in that little hole. Hold it with these diagonal cutters gently. And fold that in half. Making a U shape at that end. Using a U shape in this drill. A U eye bolt that's opened up a little. Don't pull on the wire too much or they'll break. The alloy's really not that strong. But they sure wind up easy and they're pretty forgiving in how they look. I trim off the end. In case you need to see that again, you're in luck, we have another one. Clamp down. Put the end in the little hole. Hold it with the diagonals. Use the eye bolt. Don't pull. I don't want it to jump off from under the clamp, but it held okay. Trim that off. Okay. If we look back at our order, I realize that for the kiln that we're making, this needs to be stretched to 167 inches so it can go around, I think, twice. To stretch this to the right length, I vise up one end. I use a tape measure that I put a little hook in the end. And I use this rod, hold it. And I know that as I stretch it and then let go, there's some spring back. It returns quite a ways. I'm looking for 167, and I usually add about 30 inches. So let's say I'll stretch it to 200 and see what I get. Okay. If I come out here to 200 and stop and go back and measure it, I get 153. 153 is 14 inches short from 167. So I'm going to go to 214. And lo and behold, I get 167. Okay, this element is going into the wall of a round kiln. So I know to bend it at a 90-degree angle on both ends. If it's a floor element, I would leave it straight. Okay, and then I'm shipping these to somebody, and I just wind them up. I've got tags for them, a new set of connectors. Put the tag on the element, not on the bag, because the floor and the top and the bottom and whatever could be different. Bag it, tag it. Ready to go. Thanks for watching.